when we understand AI properly, not just as data processing improvements, as machine learning does, but also as a philosophical project, then AI explains the mind as a synthesis of control theory and the theory of representation, which is a combination of functionalism, which means that we describe objects as functions or recognize that all objects are being constructed over their behavior, and computationalism, which is a metaphysical position about representation, which basically says that every object or every process can be represented by state transitions and characterized by these state transitions. It's a very general, generic position. And the alternative to computationalism in our field and also in physics is non-constructive mathematics, I would say. If you properly want to formalize this, non-constructive mathematics might engender some form of hypercomputation, representations, and processes that go beyond mere state transitions. And the problem with these hypercomputational languages and this non-constructive mathematics is, as Gödel has found, they are difficult to specify in such a way that they don't lead into contradictions. And I suspect that when we look at this in a more general way, it turns out that what mathematics is actually trying to do it generalizes over thought, over the manipulation of representations. It generalizes in such a way that it's does not just apply to the minds of mortal mathematicians, but to any kind of possible mind, right? To God's mind, to AI minds, to alien minds. So it talks about what's possible in representation in general. And you could say that the formalization that mathematicians come up with is something like a generalized programming language for thought. And what Gödel famously discovered is that the specification that he had been using up to this point cannot be implemented without running into contradictions. And if you are a computationalist, you think to exist is to be implemented. And so if you are talking about properties that cannot be implemented, like Russell's famous antinomy, that you can, for instance, use the example of if a village in which there is a barber that shaves everybody who doesn't shave themselves, who shaves the barber, right? The barber is an object that can be specified in this mathematical language that Gödel is using, but it cannot be implemented. The assumption that this barber would exist leads into contradictions. And if you look in detail, that's because there is some kind of recursion in which the concept definition refers to the definition of the concept in such a way that the representation doesn't stabilize. And that's a property of the description language that he is using that requires us to make it stateful. And if we make it stateful, we basically realize that his truth definition is some kind of index that depends on the execution state of the system. And so computer scientists basically don't have an issue with this. They just switch to computational languages in which everything is done by state transitions, versus mathematicians are sometimes reluctant to give up on these barbers because giving up on them makes it very hard to talk about certain objects that mathematicians like continua and infinities and so on. That computer scientists basically say are just very large integers or the inverse of very large integers and a little bit of squinting. And so from the perspective of the computationalist, geometry is not real. It's a fata morgana that is describing the mathematics of too many parts to count. And when you have too many parts to count, you need to squint and then discover operators that give you roughly the same result for all large counts. Right? This is not a big issue for us, that we basically changed our programming language that we use to describe reality in AI. But it's a problem for a lot of physicists who checked out the code base from the mathematicians long before Gödel and haven't updated. And that might be an issue for foundational physics because it could lead to the problem that some of the objects that physicists operate with cannot actually exist. And that's also a problem for the description of mental events of consciousness that gets people who operate at this intersection of physics and consciousness, like Roger Penrose, without properly understanding that Gödel has invalidated a part of the classical formalization of the programming language that physics are using to specify reality. And so AI is, in a sense, a philosophical project that uses the computationalist branch of representing reality. And it's in the tradition of the whole attempt to formalize the mind, starting with probably Aristotle, And going on to Leibniz, Frege, Helmholtz, Lemaitre, Tarski, Wittgenstein, his pupil Turing, Wiener and Shannon, the cyberneticians, information theorists, and Church, von Neumann, and so on, the theorists of computational modeling. And people like Minsky, who basically realized that we should use computers to represent our ideas of what the mind is like.